Hello class, as we started with the polynomial chapter number 2, and in the last class we just discussed about the basic terms like what is polynomial, what are the terms, what are the coefficients, how to find out the degree of the polynomial. Now we'll talk about the types of polynomial. So polynomial is basically categorized on the basis of two ways. So we'll talk about on the basis of terms, and second way it is categorized on the basis of degree. On the basis of terms, everyone, it is classified in three ways, basically three ways. First one is monomial, second one is binomial, third one is trinomial. If more terms are there, monomial means what? Monomial means polynomial of one term, binomial means polynomial of two terms, trinomial means polynomial of three terms. If we have suppose four terms, we can call as tetrapolynomial, tetranomial also. Otherwise we used to call polynomial of this many terms, 4 terms, 5 terms, 6 terms, whatever. We are not bothered for that what kind of degree is there and how much degree is there, you can say. Let me take the example, like monomial I can take example like x square, y to the power 100, etc. They are the monomials. Binomial I can take the example like two terms, of course, x square plus 1, 2x plus 1, x minus 1, etc. Trinomial means three terms. We are not bothered for the degree. Whatever degree we want to take, we can take x to the power 100 plus 2x minus 1, x square plus 2x minus 1, y cube minus 3y plus 1. These all are the example of trinomials. So as I explained, monomial means the polynomial of term 1, binomial means polynomial of terms 2, trinomial means polynomial of terms 3. Let us talk on the basis of degree, everyone. On the basis of degree, again it is classified mainly in three ways, three different types. One is linear polynomial, second one is quadratic polynomial, third one is cubic polynomial. Linear polynomial means a polynomial of degree 1, quadratic polynomial means a polynomial of degree 2, cubic polynomial means a polynomial of degree 3. Let me take one example, linear polynomial. For example, I am taking very simple example, px is equal to x plus 1. Px I wrote over here, might be it is new for you, but it is a symbol to represent any polynomial. P for polynomial, x means polynomial in terms of x. So x plus 1 is one example. I can take another example like y, sif only y. I mean, we are not bothered for the another terms also, and it is not mandatory to take in care even. We have to see only the degree. Degree is 1, so it is linear. Another example also you can take, py is equal to y, py is equal to y minus 100, etc. These all are the example of linear polynomial. Let us talk about quadratic polynomial. Quadratic, as I said, a polynomial of degree 2. Let me take the example, x square plus 2x minus 1, x square plus 2, etc. These all are the example of quadratic. Cubic polynomial means a polynomial of degree 3. Let me take the example, x cube, simple x cube minus 1, x cube plus 2, etc. These all are the examples of cubic polynomial. So as I explained, even types of polynomial, like types of polynomial on the basis of terms and on the basis of degree. On the basis of terms, mono, bi, tri. On the basis of degree, linear, quadratic, cubic. We used to call biquadratic also. If the degree is 4, we can call as a biquadratic also. Rest all we can call polynomial of degree 5, polynomial of degree 6, polynomial of degree 7. So I hope you understood, everyone. Let us go ahead, everyone. Basically, your 10th standard syllabus is emphasizing on quadratic polynomial, moreover on the quadratic polynomial. But we will start with the linear polynomial a little bit, so it can be recapitulation for you also. We'll talk about graph of a linear polynomial. As we know, linear polynomial means a polynomial of degree 1. Let me take one simple example to explain this topic. Px is equal to x minus 1. Very simple example. Let us represent on the graph. To represent on the graph, of course we have to get few solutions. At least 3 solutions I can say. X over here and px over here on y-axis, we can say. Few values we have to fix related to your x. Let me fix the values like 0, 1, 2, 3 also, let us take. So if I will take 0, it will be minus 1. If I will take 1, it will be 0. If I will take 2, it will be 1. If I will take 3, it will be 2. Done. We are ready with the solutions. X we will take on x coordinate. Px we will take on the y as a y coordinate. This is the value of x on x-axis and the value of px on y-axis. Let me draw a rough sketch for the same. This is your Cartesian plane. As I said, this is a rough sketch for you, so you can make an original graph on the graph paper. So first point which we have to represent is 0, minus 1 will come over here, negative y-axis. 1, 0 will come here on positive x-axis. 2, 1 will come over here in the first quadrant. Same way 3, 2 will be in the first quadrant as per our record, as per our solution. We'll join it. So we got this equation, we got this graph for our linear polynomial px is equal to x minus 1, which is what? Which is in the shape of straight line. So whenever we will draw the graph for the linear polynomial, everyone will get a straight line only. Now, if you observe very carefully this graph, you will definitely find out a line intersecting the x-axis at only one point. Why I am just telling this particular things to you all? Because we have to see, whenever we are representing the graph, we have to see at what point the graph is intersecting the x-axis. If your expression, if your polynomial is given in terms of x. So as we observe, the graph is intersecting the x-axis at one point. It means that we have 1, 0 of this polynomial. Again, the new word might be for you, 0 of the polynomial. You studied in 9th standard, 0 of the polynomial. So let us discuss 0 of polynomial, especially the linear polynomial. So just see the next topic, 0 of linear polynomial. Let us talk about 0 of linear polynomial. As we know the standard form of linear polynomial is px is equal to ax plus b, where a is not equal to 0. We know about this fact that if a I'll take as a 0, the term of ax will be vanished and we will left only with the constant. So it is mandatory to have this condition that a is not equal to 0, where a and b are what? Where a and b are real numbers. I hope I am very much clear about this. The standard form of linear polynomial is ax plus b, where a is not equal to 0 and a and b are constant, they are real number. Let me take one simple example which you studied again, the previous example which I took for the graph px equal to x minus 1, and question is asked to find the 0 of the given polynomial. Suppose this is the question. So very first step, what we have to do, the expression which we have equate as 0 and get the value of x. So x equal to 1 will be 0 of the, so you can write 1 is 0 of the given polynomial. Why 1 is 0 of the given polynomial? As per the definition of 0 of polynomial, everyone, we are aware, any value of variable, any constant value of variable for which the polynomial becomes 0, that is called 0 of the polynomial. It means that if I'll replace x with 1, let us see what is going to happen. P1 is equal to 1 minus 1, we will get 0. It means that this 1 is 0 of the given polynomial. Important thing is here, how we calculated. We just equated the expression as 0. This is the first step whenever we need to find out the 0 of any type of polynomial. Either it is linear, quadratic, cubic, or whatever type of polynomial is given it to us, equate as 0 and solve for x. So whatever the value of x will come, that will be the 0 of the given polynomial. Why we used to call zeros of polynomial? Because sometime, except this linear polynomial, quadratic, cubic, biquadratic, or polynomial whose degree is more than 1, it is possible that we can get more than 1 zeros. That's why we used to call it zeros of the polynomial. Now, let us name this 0, whatever we got over here, like here we got x equal to 1. Let us represent this by the symbol. So normally the zeros are represented by the symbol alpha, beta, gamma, etc. These are all the different symbols we are using to represent zeros of the polynomial. Let us represent this as alpha. So we will call this as alpha, which is equal to 1 for this example. Now in general, if your polynomial is given in this form of ax plus b, equate this as 0 and solve for x, we'll get x equal to minus b by a. This is also alpha, we can say 0 of linear polynomial. Now we'll talk about the graph of quadratic polynomial. The main syllabus will start from here. Graph of quadratic polynomial and zeros of quadratic polynomial, and one more topic we have to discuss in this particular point, everyone: zeros of quadratic polynomial and relationship between zeros and coefficient of the given polynomial. Let us start with that. To start with the graph of the graph of quadratic polynomial, let me take one simple example. Px is equal to, very simple example, x square minus 1. And let us try to represent this on the graph. For that, let us find out few solutions as usual, as we did for the linear polynomial, everyone. X, over here it is px, y, we used to represent on the y coordinate, so y. Let me take few values of x in the ascending order. I'll start with minus 3, minus 2, minus 1, 0, 1. Let me take few more, 2 as well as 3 also. And corresponding to these all values, let us find out the values of Px. So minus 3 if I will put, of course, minus 3 square will be 9. 9 minus 1 will be 8. If I put x equal to minus 2, it will be 4 minus 1, which is equal to 3. If I put minus 1, it will be equal to 0. If I put 0, it will be minus 1. If I put 1, it will be 0. Again, if I put 2, will be equal to 3, of course. And if I put 3, so 3 3s are 9 minus 1, 8. So corresponding to all the fixed values of x, we got corresponding values of Px. As I said, Px we will represent on the y-axis. Let me draw the Cartesian plane. It is a rough sketch for you everyone, so it will be really helpful for you. So you can follow it on your original graph paper. 1, 2, 3, positive x-axis. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5, 6, 7, 8. I think this much is enough for us. 8 is maximum. Minus 1, minus 2. Of course, this is your origin. X-axis. This is the y-axis. First point is minus 3, 8. Let me take minus 3, 8 will come over here, of course. Second one is minus 2, 3. Minus 2, 3 will come over here. Third one is minus 2, 3. Minus 2, 3. I'm sorry, I need to check. Minus 3, 8. Minus 2, 3. It is right. Minus 2, 3 is absolutely right. And the next one is minus 1, 0 will come over here. Next one is 0, minus 1, that is negative y-axis. Then 1, 0, positive x-axis. Next one is 2, 3. I hope everyone are very much comfortable to represent the points on the Cartesian plane. I hope for that. You all are familiar how to represent the points on the Cartesian plane. Then as usual, we are going with 3, 8. So 3, 8 will come over here. Freehand you need to draw this everyone. Just freehand we need to draw. You will get a quite U kind of shape. This is known as parabola. What is this everyone? Parabola. And if you observe very carefully, it is open towards upward. So you can say open towards upward. So this shape is called parabola, which is, for this example, it is open towards upwards. You will get many more parabolas everyone. It might happen you will get the parabola in this shape. So you will say it is open towards downward. Correct? It is open towards downwards. So this is basically, whenever we will draw graph for the quadratic polynomial everyone, you will always get a parabolic shape. It may happen, it will be sometime open towards upward, sometime open towards downwards. We have different types of another types of parabola which you will study in the higher section. You can say in 11th standard and 12th standard. Let us talk further now zeros of the quadratic polynomial. Just put the heading even zeros of polynomial. Zeros of quadratic polynomial. In fact, zeros of quadratic polynomial. Again, I'll explain this topic by taking one example. But before that, let us talk about standard form of quadratic polynomial. So we know standard form of quadratic polynomial, px is equal to ax square plus bx plus C, where A is not equal to 0, and what about A, B and C? A, B and C are a real number. Basically, they are constant. They are known as arbitrary constant also, because they are the constant, but they are not fixed yet. Because for this different examples, they will be differ. I mean, the first certain example A will be 2, so might be in another example it will be -1 or -3, whatever. So we used to call as arbitrary constant. Let me take one simple things for you also. Let me explain very simple things to you. Whenever we will draw the graph of the quadratic polynomial, the direction of the parabola will depend on the value of A. I mean to say, if A is greater than 0, so parabola will always open towards upward direction, and if A is less than 0, then it will be open towards downward direction. Am I clear? So this thing we have to remember. Sometime in board also they have asked. It's totally depend on the A. If A is greater than 0, graph of the quadratic polynomial will be always open towards upward, and if A is less than 0, it will be always open towards downward. So let us talk about zeros of quadratic polynomial, everyone. I'll take very simple example. Suppose I'm taking example Px is equal to x square minus 5x plus 6. And the question has asked to us find the zeros of the polynomial. The very first step, as I explained to you all, whenever any polynomial is given, any type of polynomial in fact, we have to equate as 0. Means x square minus 5x plus 6 is equal to 0. Next step, of course, we need to find out the zeros by doing middle term splitting. For the middle term splitting, of course, we need to write all possible zeros of, all possible factor form of 6. We can write 1 into 6, 2 into 3, 3 into 2, 6 into 1. So out of this 2 everyone, anyone we have to take in such a way, after addition it should come -5. So I'll take of course -2 -3, which is equal to -5. Let us split this middle term as you know how is to be done. In 9th standard, in 8th standard, you studied about the factorization of polynomial. So let me continue this. So we'll get x square minus 2x minus 3x plus 6 is equal to 0. Let us take the common. X is common over here, x minus 2. Minus 3 is common, x minus 2 is equal to 0. Again, x minus 2 is common. So I'll take x minus 2 as common. So we will left with x minus 2 into x minus 3 is equal to 0. We got two factors over here. Individually we will equate as 0. Means x minus 2 equal to 0. Then you will get x equal to 2. X minus 3 is equal to 0. We will get x is equal to 3. As I explained, we can use different symbols to represent these zeros. So I am taking this one as alpha and this one as a beta. So alpha is equal to 2 and beta is equal to 3, or vice versa. We have to study further things related to the quadratic polynomial, everyone. As I said in very beginning, in the quadratic polynomial we have to find out the zeros of polynomial, which we learned how is to be find out by middle term splitting. We'll take more examples related to this. After that we have to study relationship between zeros and coefficient of the polynomial. As we have the coefficient over here a, b, and this is constant term c. So that everyone we will see in the next class. Thank you very much.